let's start then. Okay. Today topics is kind of similar to would be similar to what you will learn in your statistics and probability class. The topic entitles linear regression. Right? Linear regression is a technique that you can reduce the variation in the data and then describe that variation in the data with equations. And then you can use those equations either to do the study to understand the trends, or you can use those equations to perform prediction. Right? So we will take a look at that today on how does it work and how to create a model in Python in R using the linear regression tools to build a model and then study the behavior of the data. Note that I'm not going to teach you the basic assumptions all the way through that because I expect you have to learn that in the statistics class, and I don't want to repeat a theoretical point of view of the statistics class here. So this is what we are going to learn today. Let's jump to the topics. So the topics today comprises 4 parts. The first part will be about how to identify linear relationship. You have already seen this in the previous lectures that we take a look at the relationship in terms of the linear relationship. And then we will take a look at the concepts, basic concept of linear regression, how to form the basic equation and find the parameters or the coefficients of the equations, then how to build a model, and then use the model to perform prediction and basic evaluation, especially in terms of the measurements on the metric that we can use to indicate the goodness of fit between the model and the data, right? So by this lecture, we have now jumped from basic statistical modeling that we looked at in the 2 weeks ago to our very first machine learning models, right? So although this can be thought of as a statistical model, but yeah, it's the first step toward machine learning. Okay. So what is linear regression? We can define linear regression as a way that you explain relationship. That you explain relationship using a simple equations. In the simple linear regression, it explains relationship in terms of one variables. Okay, we have one variables x, which we use as which we regarded as input, as the independent variables in science, as the predictor, or sometimes we call that explanatory variables. So basically, x is something that you want to use to explain the variations of y, and y would be the dependent variables. Is the variable that would react to the change in x. So by using simple linear regression, we explain the relationship with just one equation, y equal mx plus b, the linear equation. Okay, so when we talk about relationship, you can take a look around you and then see certain types of relationships, different types of relationship. The relationship can be deterministic. Deterministic relationship like the conversion between Fahrenheit and Celsius, or you can see the relationship in the statistical sense, that the relationship itself contains variations in the data. Right? When such variations occur, you would want to explain the variation or the dependency between the two variables, the x-axis and the y-axis, with certain relationship like this one. This is like y hat, or the y that describes the line here, equal 300 something minus the coefficient, the slope, and the value of x. Right? By explaining it like that, you are explaining the relationship between the two variables with the coefficient of that multiply with x, or sometimes we call it slope, and another coefficient that add to the x term. We call that the intercept, right? You learn that in your stat class. So when we look at the statistical relationship, you may find that in many places, like in the height and weight relationships, in the blood alcohol content and consume alcohol consume, different people react differently. Spending amount, number of spending for the credit card, number of exercises per week, and the weight that you lose for that exercise, or the like credit line that you have with the company, and the credit usage, how much you use, and other things, many other things that can be found here. Okay, you can find such statistical relationship all around the world, or all around you, if you take a look at the nature. So how to describe those relationships? Relationships like that can be explained with the tools that allow you to study the linear terms, and such a tools are scatter plot, right? You can use scatter plot to plot and see the relationship between two variables, and then once you see that, you roughly know that they kind of depend on one another if both forms the lines, right? That the like the dot cloud that you see in the scatter plot forms something like a line there. Or you can use the statistical measurements like correlations, which allow you to identify potential variables that may vary together through the covariance. These two things you have already seen that, so I will go quite quicker here because we have seen this we have done this already before the midterm.